So in this video, we're going to talk about just how to enter the answers for questions 7 and 8 into the computer. I'm doing homework 10.2. I'm going to go ahead and scroll over and zoom in so this looks a little bit better. We're asked to convert the following radical to an expression with rational exponents and simplify if possible. What does that mean? Radical is just a fancy word for root, and rational is a fancy word for fraction. So what they're asking us to do is to write this root with a fractional exponent. So we've learned that square rooting is to the 1/2 power, so I want my answer to be y to the 1/2 power. Now if I hit y and my little yellow arrow, I want to choose this this figure right here. The x right there isn't going to be entered. It's just this little square saying, hey, you can put something up high where the exponents lived. So notice that now my cursor is above the y, and I want to write a half there. If I just do 1 divided by 2, look how that's not what I want it to write. I'm going to do 1 divided by, and then go ahead and put my 2 in my denominator. I'll bet alternatively we could insert a fraction. Yep, you could insert a fraction as an alternative strategy and do 1 for the numerator and 2 for the denominator. Save. And the syntax is okay, meaning the computer can read it, and that's exactly what I want to write. I want to say the square root of y and y to the 1/2 power are notations for the same thing. I'm going to hit submit, and we've done great. All right, so now let's go ahead, and when I'm using that little yellow arrow to help me, but the way that they're writing right here, you could totally type that in on your keyboard, but sometimes it's a little less intuitive unless you've done this before. So I'm going to go to question 8, and it's the same kind of question. Convert this following radical to an expression with a rational exponent and simplify if possible. And we're assuming that all variables are positive here. Later, we might be if we don't assume that variables are positive and we're taking even roots, we need absolute value. But that's totally anecdotal. Don't stress about that. We're just practicing going from root form, from radical form, to rational exponent form, to fractional exponent form. I want to go ahead and do this problem on a separate piece of paper just so that it helps a little bit. All right, so we have learned that something to the 1/n power is notation for the nth root. N can be any number, square root, cube root, fourth root, etc. We've learned that the denominator is the root that you are taking. In general, x to the m/n is notation for the nth root of x to the m, which you can also write as the nth root of x all to the m. And don't stress, we're going to do some examples. If you just remember the denominator is the root that you are taking, you are all set, right? You have an option of taking the nth root of x to the m, or first taking the nth root and then raising something to the nth power. So let's do a couple little examples, and then we'll go ahead and do problem number 8. All right, so let's investigate what 64 to the 4/3 power is. Now, 64 to the 4/3 power, one way of thinking about this is that this is 64 to the 1/3, and then all to the power of 4. We know that 64 to the 1/3 is the cube root of 64, and that's all being raised to the power of 4. The denominator is the root that you're taking, and in this case, because 64 is a perfect cube, I would like to take the cube root first. I don't want to do 64 to the 4th, that's some big giant number, and then cube root it. I mean, I could, but 64 cube rooted is 4. And why is that? That's because 4 times 4 is 16, times 4 is 64. So 4 cubed is 64. And the numerator is our good old notation for repeated multiplication of the base, right? So here I have 4 times itself 4 times, which we can just do on a calculator if we want. 4 times 4 times 4 times 4 is 256, right? And that's nice. All right, now let's go ahead and do example 8. Example 8 was the 6th root of y cubed. So all that we're practicing here is noting that the root that you're taking is the denominator of the fractional exponent. So my answer is y to the 3/6 power. Now 3/6, that fraction can be simplified, right? 3/6 is a half, and it's y to the 1/2 power. Now, if you went ahead and wrote y to the 1/2 power on a test is square root of y, that would be great. But let's go ahead and read the directions, because your calculator, and don't stress because you have unlimited tries, but your calculator, or the computer that is wanting it to be expressed in fractional exponents. So this is okay. Those things really are equivalent, but let's go ahead and put those answers in and read those directions carefully. All right, so the directions are to convert from radical form to the rational exponent form, meaning I want my answer to be with fractional exponents. That's what they're looking for. And the computer's not a person, right? So it needs to have it programmed in a certain way. So go from radical form to rational exponent form and simplify if possible. So what we want to write is y to the, grabbing this, not 3/2, or sorry, not 3/6, because we can simplify 3/6. 3/6 is 1/2. Save, that's what I want to enter. I'm going to hit submit, and we did great. Now notice I'm going to go ahead and write square root of y, because y to the 1/2 and y and square root of y are the same, but the computer's going to mark me wrong. Not because I'm wrong. Here's square root of y. Oops, not show answer. Submit. And you see how it's wrong, square root of y. The reason being, it's asking us to convert from radical form, convert from the root form to another form, because we're practicing this notation. The other form is the fractional exponent form, the rational exponent form. And here I've left it in root form, in radical form. So that's why we need to do y to the 1/2. There I am putting it in as shorthand and not using the little yellow arrow. That's what they're looking for. All right? This concludes our video.